In this circuit we have one capacitor and single pole double throw switch. Our task is to find voltage across this capacitor. Obviously this can be done by calculations. It is quite an easy task. This voltage will exponentially rise from 6 to 12 volt after changing position of this switch. And now PSpice simulation. At first, simulation by means of the non-schematic version. We may model this switch a single pole double throw or changeover switch by two switches, single pole single throw switches, T open and T close. But unfortunately, in this version of PSpice, to model such a switch we need 4 lines, 3 elements and model for the switch. It is much easier than if we have a switch or switches in the circuit. To use, please observe, this is our circuit after adding them switches, quite complex. However, originally it is very simple circuit. So it is this is analysis simulation result. This is a schematic version which is recommended when we have switch or switches. So this is a switch which is opened at t equals 0, this switch is closed. That way we have modeled this changeover switch. We have obviously set the values of these switches: t open 0, transition time 1 nano, and r close, r open. Same values for both switches. Then a transient analysis setup, 12 microsecond is the final time. No step ceiling for this simple circuit. After saving this data, we may start simulation. When simulation completed, we may add trace, and this trace is the voltage. We have to extract schematic netlist to examine what is actually a number of this node. This number is 3, so our trace is trace of V at node 3. Okay, very briefly let me repeat this simulation live. Data circuit diagram already stored in computer memory. We had values of all these elements. Also we have these two switches, values for these two switches as discussed before. We have a transient analysis setup, 12 microsecond, and we may start a simulation. It takes a second or 2 seconds. Yes, we have a blank window, and now we may add a trace, add trace, and our trace expression is voltage at node number 3. Okay, and this is the voltage exponential curve from 6 to 12 volt. That way we have completed a simulation.